Alright guys, today we're going to do 2-2, solving inequalities by adding or subtracting. Our objectives: solve one-step inequalities by using addition, solve one-step inequalities by using subtraction. Okay, solving one-step inequalities is much like solving a one-step equation. To solve an inequality, you need to isolate the variable using the properties of inequality and inverse operations. Okay, so just like with your addition and subtraction properties of equality, these are inequality, okay? So if you add something to both sides of the inequality, then you're keeping that inequality balanced, okay? Just like with subtraction. If you subtract something from both sides, you're keeping that inequality balanced. These inequality properties are also true for all of your inequality symbols. Okay, so we are going to solve inequalities in graph. Okay, so we need to isolate the variable x. Inverse of addition is subtraction, so I have x is less than 8. Okay, how did I know this? This is the inequality property of subtraction. Then we need a graph. Is 8 part of our solution? It is not, so it's an open circle. Our solution is all real numbers to the left of 8. So that's how you would graph it. Alright, next one. Okay, we need to isolate our variable d. So we're going to add 5 to both sides. When we add 5 to both sides, this is our inequality property of addition. So we have negative 7 plus 5 and get negative 2. These cancel out, so you have d. Then when we graph that, we have an open circle on 2 because we're not including negative 2 in our solution. And it's all the numbers that are greater than negative 2. So your solution set goes to the right. Guys, and if you want to test it or check it out. Pick one of these numbers, okay? So let's pick 10. If you substitute 10 in for 5, 10 minus 5 is 5. Is 5 less than, is 5 greater than negative 7? Yes, we've checked. Let's pick a number down on this side. Let's pick negative 10. Negative 10 minus 5 is negative 15. Is negative 15 greater than negative 7? This is false. That's why the numbers to the left of negative 2 are not part of your solution. Okay. Now what's different about this one is your variable is on the right side to the left. So it's a little bit tricky when we graph it. But let's go ahead and isolate our variable. So inverse of subtraction is addition. This cancels out to n. Bring down your inequality symbol. And we have 1 2/10. Okay. When we graph that, are we going to include 1 2/10 in our solution set? We are, because this says 1 2/10 is greater than or equal to n. Okay. This is greater than or equal to n. N is all of your real numbers, okay? If this is confusing you guys, flip this around, put your variable on the left side, but you must flip the inequality symbol when you do that. N is less than or equal to 1.2, less than or equal to 1.2. But at the algebra level, you should be able to read this one and graph it at the same time. Since there can be an infinite number of solutions to an inequality, it is not possible to check all the solutions. You can check the endpoint in the direction of the inequality symbol. And guys, we've already been doing this as we've been working some problems, so I'm going to go ahead and skip and go to the word problem that we have here. All right, Sam has a gift card, or Sammy has a gift card. She has already used $14 of the total value, which was $30. Write, solve, and graph an inequality to show how much more she can spend. Okay, so let's see what this is saying. This is saying that the amount she can spend plus the amount she's already used equals, well, it's not going to equal. Let's see, what's the appropriate word? It says Sammy has a gift card. She has already used $14 of the total value, which was $30. Write, solve, and graph an inequality to show how much more she can spend. Okay? So how much more she can spend. Okay? So, amount she can still spend, amount she's already spent, and then the most she can spend right here is $30. All right, so let's write the inequality. We're trying to find out what this is. How much has she already spent or used? $14. All right, at most. Can it equal 30? Yes. Can it go above 30? No, so we need our less than symbol there. Okay, then go ahead and solve this like a one-step inequality. Inverse of addition is subtraction. Okay, write and solve an inequality. Well, here's my inequality. Here's where I solve the inequality. And what else do we need to do? We need to graph. Can we include the 16? Yes. And anything less than 16. All right, one more. I'm going to let y'all try this on your own. I'm going to work it out up here, so if you get stuck, you can look up here or look at your computer or look at the iPad, whatever you're using there. Okay. So you've got the amount that she can add to the highest bid, and it has to be less than or equal to $5.50 because it says it can be no more than $5.50. So set up your inequality, solve for your variable. So the money that she has left to spend is less than or equal to $75. All right, that's it for lesson 2-2. Have a good one.